day. Today we'll be discussing about helical springs, or today we will derive this torsional stress that is experienced by helical springs. Okay, so in order to derive the formula, let's have this figure wherein helical spring is stretched by an axial load P. Okay, so how do we determine the stress that the spring is experiencing? We will take a plane MN and cut a portion of the spring. Okay, so by the looking at the free body diagram, this force P must be balanced by this one, P sub R. Okay, so by summation of forces along the vertical, we find out that PR must be equal to P. Okay, so this one. And then, uh, there is no force involved in the horizontal direction, but rather there is a moment because P and PR is not on the same axis. Okay, so if we get summation of moment along this line, we can get that uh, this one you have a torque PR, okay, must be balanced by okay. So if we get the moment around here, so you have certain moment, or this one produced by PR, which is force times the radius PR. Okay, so na ay moment na paana. So dapat ang imo ang spring pod is counteract na niya with a counter torque T. Okay, again, ang para to maintain equilibrium, ang value ani nga T is also P times R. Okay, so diha nagikan. Now if we enlarge this one, enlarge nato ni siya, this would be the magnified view of the spring cross section. Okay, you have torsional stress tau 1, or this is what we call the direct shearing stress. No, it is caused by this load P. Okay, kaning load P. This is what we call the direct shearing stress because of the load P. And then variable na torsional shearing stress kani siya tau 2 because of the torque, mo ni ang orientation. Okay, paana man ang imo ang moment, so mo ni ang orientation. This is what we call the variable torsional shearing stress caused by the twisting couple, this one. Okay, we find out that the resultant at point B, resultant shearing stress, is the sum of vector sum of the shearing stresses. Okay, so at point B, the stresses, kani sa nga stress is opposite. You have tau 1 padong down, kaning tau 2 pasaka. So the resultant ani is just the sum ani nilang duha. Therefore, at the inside fiber kani, the resultant, the two stresses kani nga stress is collinear, no? Same sila direction and in the same sense. Okay, so ang sum ani nila produces the maximum stress in the section. So the maximum stress always occurs at the inside element of the spring wire, no? So ang maximum stress ko no is diri nga part. inside element sa imo ang spring. Okay? Kay maximum siya because the same na ila ang orientation. Kung i-add man gud nimo ni, so gamay na lang ang mabilin ani kay opposite man sila direction. Okay? So therefore, the total stress, shearing stress is combination of tau 1 plus tau 2. This one. Wherein ang imong tau 1 is direct shearing stress man eh. So, P over A ra ni siya. Direct nga shearing stress. Plus, tau 2. Ang tau 2 is, that is the torsional shearing stress. So, torque R over J. No? So, na siya. So, ito ning i-substitute there eh. We have this equation. The total shearing stress is 16 PR over pi d cube times 1 plus d over 4R. Okay? So, mo ni ang equation nimo for the shearing stress na experience imong spring. Okay, so it should be noted that the preceding discussion contains error. So, naada na yung error nga equation nga naman. Because the torsion formula was derived with straight bar. No? Kaning equation is for kung man straight bar. But ang imo ang spring is kung man na siya. May pagka-curve man na siya. No? Curve man ang imong spring. So there is error. This error is of significance in heavy springs. No, kung heavy ang springs kay significant daw. Okay? So, to account aning curvature aning imong bar sa imong spring, RAM Wall has developed the following formula that takes account of the initial curvature of the spring wire. Okay? Okay, so yan yung gi-modify. Yan yung gi-modify ng equation. So, sa yung gidugang, you have this one. The tau, maximum tau is 16 PR over pi d cube times quantity of 4m minus 1 over 4m minus 4 plus 0.615 over m, or ang m is the ratio of the diameter, d over small d. So, kanang d nga dako is kani diameter sa imong ang spring. No? Whereas ang d nga gamay is kaning diameter sa wire na imong ihimong spring. So, mo na siya. Okay, you have in light springs where the ratio m is large, para sa mga light nga spring, dako ang imong m nga naman kay gagmay makaya na o kani denominator. So the first term in the parenthesis approaches unity kani process unity daw ni. So compare with equation 3-9, mo na rin kung 4 light springs, no, kung ang m nimo is large, 16 PR over pi d cube times 1 plus 0.5 over m. So, for heavy springs kanim gamiton. No, kay mas accurate ning 3-10 as compare sa kani. And then for light spring, so mo ning light spring meaning ang m nimo is large. Okay? Let's have an example later on. Now, let's proceed with the deflection sa imong spring, no? So, pag binat ni mana, siyempre mo deflect na imong spring. So, all spring measured along its axis is caused by torsional deformation of the spring wire. If we temporarily assume all the spring in figure 3.15 to be rigid except the small length dl. Okay, so this is the length dl. The end A will rotate to D. So, di ba? So, tama siya. Kung pag-inat ni mo ani, tuyok mo ni. Manap ni. So, ang A, maabot dire sa D. And then, through the small angle d theta. D theta daw. D theta daw ang deflection from A to D. Because the theta is small, the arc AD, arc AD is just equal to BD, AB, AB, tama, AB times the theta. Ang AD ko na value na is AB times the theta. Okay. Therefore, from similarity of triangles ADE and BAC, so ang ADE and BAC, so ADE, BAC. Okay, by similar triangles, we obtain AE over AD. AE over AD is equal to BC over AB. Tama. Okay? Imaro ring ratio kaning gamay nga triangle o kaning nga triangle. BAC. And then, ang AE nimo, AE. Ang length ani niya is small d, d delta. D delta. This one. Muna ang imo ang deflection over ang AD, sa value sa AD. This is AB d theta. AB d theta is equal to AB. What is BC? BC is R. No, the radius sa imong spring. R over AB. So, tama ra ni. And then, cancel ng AB. Mabili na lang, d delta is R d theta. So, kani daw nga deflection, small deflection is equal to R d theta. Ng R d theta. R times kani. R times this angle, R d theta. Okay? And then, applying equation 3-1. So, unsa ng equation 3-1? Katuning, tanaw na ito na equation 3-1 be. Equation 3-1 is ang katong theta is equal to TL over JG. Ani. So, ilisda nato ni. So, this will become R times T. TL over JG. Okay. Ito na lang yung ikuan. Solve sa board. Okay, so again, in our objective in deriving this equation is to get the spring deflection. Okay? Spring deflection meaning kung mauni ka dako ang mong load, pila ang yaang stretch or ang yaang deflection niya, no, or deformation. Okay, so in order to get that, so ang deflection ano niya is kani small d delta. Based diri nga figure. No, kay mao man ang change sa position sa kaning point. Okay. So unsa na to na pagkuha? We will by similar triangle kani nga small triangle og ABC. No? A no. Triangle ADE. Ato na siyang similar triangles with triangle ABC. Okay, so unsa na siya? You have AE over AD is equal to BC over hypotenuse AB. Tama ba? AE over AD. Now, kaning AE, mo man yung atong gipangita. Kaning small delta, mo na yung length na niya. No? Over what is AD? Base dire, ang AD is equal to kani AB times d theta ni. Arc length naman na siya. Okay, may ana naman na. AB d theta. Okay. AB times d theta. Ang BC nimo kani BC is R over AB. So cancel ang AB. Kuha na to nga d delta is R d theta. Okay, R d theta. But based sa equation 3-1, okay, ano man po ning d theta? Ang tanat ng other value. Diba? Theta is TL over GG. Yan kay for d theta man ito pakitaan. So, itong aning i-differentiate. D theta is kani constant maning T GG. Dil constant ano is kaning DL. So, mo sa ano equivalent niya. May mo na rin yung R T G over G DL. Okay, but ang imo ang T is ganin T, ang T nimo is force times radius. So may mo ning PR. So D delta is PR squared. PR squared over GG DL. Okay? And then, we will integrate this one. Okay, kanina man itong ipangitawan. Okay, for a small length raman ni. Ito ning integrate sa tibuok length. We'll get that delta is PR squared constant raman ni over GG times L. Okay? Okay. But ano ning reason? But kaning L nimo, L is unsa man ang total length ani? Kung naa kay spring ana, ang length ani niya is just equal to unsa man? Circumference no times pila ni kabuok. So L is just 2 pi R N. 2 pi Rn. No, kung pila ka coil, kunin mo pila ka coil. Kaya ang spring, ana-ana ramang ko na. Ang total length ana niya, kunin mo ni times the circumference. And then, replace J, di ba? Ang J mo is, ano sa galing ng J? Polar moment of inertia, pi d to the 4th over 32. So, we will obtain 64 pi r cube n over g d to the 4th. Okay, again, kaning r is kaning, no? Ang kaning d is diameter aning wire nimo. Ano siya? Okay, so kani nga mo ni ang imo ang equation kani. This is expression for spring deflection neglects the deformation caused by direct shear. Okay, so this is for mo ni ang deflection caused by pag ano mo no, pag inat. Pero yun sa book is zaman. Kulang pa daw ni. Wala daw na account ang direct. Anyway, ang direct tawag ni deformation caused by direct shear, which is delta prime PL over AG. PL over AG, which is equal to 8 PRN over GD squared. So, mo na ni. I-add down ni mo ni. Pero usually, kay negligible. So, kanira yung gamiton. Pero kani. Ipakita lang nato nga na ni. Anyway, let's have an example. So, we already derived that the elongation of the spring is given by this equation, 64 PR cube N. Okay? 64 PR cube N. And then, over GD to the 4th. Okay, so if we, kung ato ning i-divide by, ang P ni mo, ato ning i-arrange, maporma siya din ani, P over the elongation, mahimo ning equal to GD to the 4th over 64 R cube N. Now, kaning ratio is what you call the spring constant K. No? Spring constant K. Unit is Newton per meter or Newton per mm. Okay, so unsa importance ani? Importance aning K is kung daghan kayo og spring na involved, lahi man na og K, no? So, mong buhaton, kung naka-series siya, pwede naman siya isolve ang total K. Unsa ang total nga spring constant ani nila is makuha nimo using this equation. 1 over K is equal to 1 over K1 plus 1 over K2 and so on. Kung nakaparallel pod siya, ani ang setup, ang K nimo will be imurang i-add, no? Algebraically, no? K1 plus K2 plus K3 and so on. So mo ay advantage ani. Okay. Taas man gud ni siya kung solution. So timan-an na ni man nga ang K is GD to the 4th over 64 R cube N. So let's have this example. Okay. Let's have this example. Okay, so let's have this example. A load P, this one, is supported by two steel springs arranged in series as shown in the figure. So this is arranged in series. The upper spring has 20 turns of 20 mm diameter on a mean diameter of 150 mm. So kung mayon ka og 20 mm diameter wire, so ang kani diameter na ani nga wire. Kung mean diameter, mao ni ang diameter ani. The lower spring consists of 15 turns of 10 mm diameter wire on a mean diameter of 130 mm. Determine the maximum shearing stress in a spring if the total deflection is 80 mm and rigidity of 83 gigapascal. Okay? So we're asked to find the torsional shearing stress. Again, sa itong equation sa torsional shearing stress. Equation sa torsional shearing stress is kani. No? You have 16 PR over pi d cube times 4m minus 1 over 4m minus 4 plus 0.615 m. Okay, so unsa ang unknown dere? Ang unknown na lang dere is diameter sa wire given. Ang m is ratio raman na siya ani diameter given na po na. R is the radius sa imong spring. So ang unknown na lang yun is P. The load. Unsa ang load kay man given. So mao na tong pangitaon. Una first no, ang load niya P. So unsa man po na nimo siya pagkuha, you need to have another equation, no? Sa may given sa problem, given kag total deflection. So kanina siya deflection. So base dere RGD to the fourth. So kani imong gamiton, no? Kani imong gamiton. Kani. Okay, so ato ni siyang i-solve. Okay, so let's solve the problem and these are the given, no? The spring 1, spring 2, diameter, small nga diameter D1 is wire diameter. Kaning D1 nga capital mo ni is D1. No? And then, di ba? Para makuha na to ang torsional shearing stress, we need this P. Okay? And base sa equation, P is equal to K times delta. Tama? No? So, ang buhato na to is, pangitaw na to una ang kani, kaning K. Take note nga mo yung equation sa K. Pangitaw na to ang, para makuha na to ang P, pangitaw na to ang total nga K. Diba? Series man eh. Ang total nga K is 1 over K1 plus 1 over K2. Hindi mo klaro siguro. Silaw sa talin ako. Dire. 1 over, total K is 1 over K1 plus 1 over K2. Diba, lahi po ng pag-solve sa book, pero I'll show you another way. Pwede using aning spring constant. So, pangitaw na ito ng K1 and K2. K1 is GD to the fourth over 64 R1 cube and 1. So, mahimo na siyang 83 times 10 to the 9 Newton per m squared times D1. Isa ang D1. 20. MM na. So, may mo ng 0.02 to the fourth over 64 R1. So, unsa ang R ani? 75, di ba? R1 is 25 mm. So, 0.075 cube. N1 is 20. So, kung imo niyang kalkyuhon, K1 is 24,592.59 sa unit Newton per meter, K1. K2. Let's solve K2. Again, 83 times 10 to the 9. D2. So, 0.01 to the fourth over 64. Ang R ani is 65. Tama? 65 ni R2. 65 mm. So, 0.065 cube times N2. Bilang N2? 15. Therefore, K2 is 3148. 3148.23 Newton per meter. Okay, so naana tayo K1 and K2. Ganitong pangitaon, total K. So, ang total K is 1 over K1 plus 1 over K2. So, may maning 1 over, ilang K1? 1 over 24,592.59 plus 1 over 3148.3. Calculate na nimo, total K is 2790.95 Newton per meter. And then, ito ning substitute dere, P is 2790.95 Newton per M times 80. So, 0.08 meter. So, cancel. Ang P nimo will be 223 Newton. Okay? But, ang ipangayo is shearing stress. No? Shearing stress. Again, I will now ang base sa RM wall nga equation, shearing stress is 16 PR over pi d cube times 4m minus 1 over 4m minus 4 plus 0.615 over m. Okay? So, for spring 1, tau 1 is 16,223 times R1 0.075 over pi, ilang D? 0.02 cube times, kung ano yung reason? Times pila ang M. Ang M nimo is capital D over small d. So you have 150 over 20, ilan na? 7.5. 7.5. Tama? So 7.5 times 4, 30. So you have 30 minus 1 over 30 minus 4 plus 0.615 over M nimo 7.5. Okay. So, stress sa spring 1 is 12.7 megapascal. Again, pag solve mo dapat na ay unit dire para makabalo ka. Ito ning gidiretso. For spring 2, you have 16,223.065 over pi, pila ang B, 0.01 cube times pila ang M diri. M2 ang spring 2. M niya is 130 over 10. So this is 13. So makakay 13 minus 1, 13 minus 4, 0.615 over no. Dili 13. Times 4 mo na 13 times 4. 52. 52 ni. So, kanin may 13. Okay. So, the answer would be 81.9 MPa. So, ano na yung answer, no? Stresses man yung mga. So, that's it. Please solve again kung what if gaana ana dayon gaana diba mura man yung gitong circuit sa electrical, no? Series then parallel. Buhaton ninyo ganyan na purong kwaon ang total K ani, then naka-series na nila yun. Mura nag-simplify niyo ba? Mura ana na dayon. And then, kung ano po naman total K ana. So, ana